Let's learn the introduction to artificial intelligence today. Now, welcome back to Artificial Intelligence Introduction class. In today's class, we will learn how to build a knowledge graph. So, basically, we can break down this part into 4 different sections to talk about. So, let's move on to the first part, knowledge extraction. A knowledge graph is a database that organizes information using visual graphs made up of entities, relationships, and attributes. Entities are basically objects that can be anything, like people, places, organizations, or products. Each entity has a unique identifier and a set of attributes that describe it. Relationships, which are represented as age or arrow between entities, describe how entities are connected or interact with each other. Attributes are properties of entities, like person's name, gender, birth date, or occupation. By using this approach, large graphs helps us organize and make sense of a lot of information and can even be useful semantic search and reasoning. Now, the next thing we need to concern about is how to store this knowledge. A knowledge graph is a connection of entities, relationships, and attributes that are organized into a graph-like structure. The objects that are stored in a knowledge graph can be divided into several categories, each with its own specific purpose. Firstly, basic attribute knowledge provides the fundamental information about an entity, such as its name, type, and identified code. This information forms the basis of an entity identified and helps distinguish it from others. Secondly, related knowledge describes the semantic relationships between entities, like hierarchical, associative, and interactional relationships. This information helps to reveal how entities are connected and how they interact with each other. Thirdly, event knowledge captures information about events related to that entity, like a person's date of birth or a company's founding date. This type of knowledge is used to describe an entity's history and development, and how it changes over time. Fourthly, time series knowledge describes how an entity changes over time, like stock price and temperature. This knowledge is used for trend analysis and forecasting. Finally, resources class knowledge refers to the resources and classification information in a knowledge graph, like a grocery or a classification system. This knowledge helps users understand the meaning of the context of entities and support applications like NLP and semantic research. Overall, the objects stored in the knowledge graph serves to provide a rich, interconnected understanding of the world around us and allow us to make more informed decisions and predictions. There are 2 main ways to store knowledge: table structure and graph structure. Table structure is based on a relational database where knowledge is stored in tables. Each table represents a type of entities or a relationship, and each row in the table represents a specific entities or relationship. Table structure is easy to manage and query and works well for simple knowledge models. However, as the knowledge models become more complex, table structure may not be able to handle the semantic relationships and massive amounts of knowledge. Graph structure, on the other hand, is based on the graph database, where knowledge is stored as nodes and edges. Each node represents an entity, and each edges represent a relationship between entities, like parent-child, sibling, or friend. Graph structure is flexible and able to capture complex semantic relationships, and it can handle massive amounts of knowledge. It's also suitable for a variety of knowledge models. However, Graph structure is more complex to manage and query than table structure, and it requires specialized graph database technology. The choice of which structure to use depends on the complexities of the knowledge model and the specific needs of the application. There are two main types of tools used for knowledge storage: those based on table structure and those based on graph structure. Table-based tools are typically relational database like MySQL, Oracle, and Microsoft SQL Server. They store knowledge in tables which can be queried using SQL and other standard query language. MySQL is popular or open source relational database that's known for its high performance, reliability, and ease of use. It's used in a wide range of applications. Graph-based tools are typically graph databases like Neo4j, AringoDB, and OrientDB. They store knowledge in form of nodes and edges, which can capture complex semantic relationships and support massive knowledge storage and querying. Neo4j is one of the most popular open-source graph database, known for its high performance, ease of use, and scalability. It's used in applications such as social networks, recommendation systems, and knowledge graphs. In summary, table-based and graph-based tools are common tools for knowledge storage, each with its own strengths and weaknesses. For simple knowledge models, a relational database like MySQL might be more suitable, while for more complex knowledge models, a graph database like Neo4j might be a better choice. And then let's look at knowledge fusion. Knowledge fusion, also known as knowledge integration, refers to the process of combining information from multiple sources to generate a more comprehensive and accurate representation of knowledge. The goal of knowledge fusion is to overcome the limitations of individual sources of information by leveraging the strengths of different sources and producing a more complete and reliable picture of the underlying knowledge. In practical terms, knowledge fusion involves techniques such as data aggregation, data normalization, data reconciliation, which allows different types of data to be combined in a meaningful way. This process often requires sophisticated algorithms and machine learning techniques to extract useful information from different sources, identify similarities and differences, and integrate the information to a unified knowledge representation. Knowledge fusion has many applications, including in the fields of artificial intelligence, data mining, and knowledge management. For example, in the context of knowledge graph, knowledge fusion might involve integrating information from different domains, such as scientific literature, social media, and public databases, to build a more comprehensive and accurate knowledge graph that can support advanced search, recommendations, and decision-making. Once you've got your knowledge stored up, then you can start doing some knowledge inference. Knowledge inference refers to the process of deriving new knowledge from the existing knowledge using logical reasoning, deduction, and induction. In other words, it involves drawing conclusions or making predictions based on what we already know. In the context of knowledge graphs and other knowledge representation, logic inference is used to discover implicit knowledge that is not explicitly stated in the graph. For example, if a logic graph contains information that John is the parent of Jane and Jane is the parent of Tom, we can infer that John is the grandparent of Tom, even though the fact is not explicitly stated in the graph. There are different types of knowledge inference, including deductive inference, inductive inference, and abductive inference. Deductive inference involves drawing conclusions that necessarily allows from a set of premises or assumptions. Inductive inference involves drawing generalizations or predictions based on observations or evidence. Abductive inference involves making the best possible explanation for a set of observation or evidence, even if it's not certain or conclusive. So that is all about the introduction of knowledge graph.